Good morning, everyone. My name is Youngmin Park, working at the marketing team as product marketing manager. I am very pleased to have an opportunity to proceed the basic training for our business partners and Doosan Robots users. Doosan Robotics just started running Academy from 2021, and as you already looked at the curriculum that we've delivered through RoboLab email, you can submit the training application form to RoboLab Manager, filling out training name, requested date, and questionnaire. This training will be conducted through PowerPoint and some robot videos. We will have Q&A time after each chapter. For more effective training, please feel free to ask us by chat of Zoom, and we will answer your question even if we are late. Also, please change your nickname to your company name/name for attendance check before starting the training. From now on, we will proceed with Doosan Robotics basic training. First of all, let me introduce the training contents. Basic training introduces the components of the Doosan robot, each part and function including installation. Next, explain about electrical interface, safety recovery, manual operation, and general robot configuration. The programming such task creation, teaching, safety zone setting, and etc. will be covered in core training. So, if you need to join this class, please send us your training application form through email to RobotLab Manager. The Doosan robot is a 6-axis vertical multi-joint robot similar to human arms. It is different from horizontal multi-joint robots that move in a horizontal plane, called orthogonal robots or SCARA robots, where each joint moves in parallel. Generally, the collaborative robot uses 1, 2, 3 axes for position movement and 4, 5, 6 axes for angle movement, and has a spherical working space for any angle representation at any location. First, M-series components, you can receive 2 boxes after purchase. The first box contains a robot. The second box contains a control box, a teach pendant, a power cable, a robot cable, and manuals. The teach pendant is separately packaged in the second box. Next is A-series component. Like M-series, the first box contains a robot. The second box contains a control box, an emergency stop button, a power cable, and manuals. For A-series, the robot cable is integrated with the robot, and teach pendant is not included in the second box. It is treated as an optional item, not standard component. On initial boot up, you can control the robot by downloading .platform. a window-based PC teaching pendant software from the Resource Software menu on RoboLab website. We will see this website later. Here is a list of other components. Please note that cockpit is available as an option for all series and models. All products are equipped with cockpit at factory status, but you must purchase a license key to use the cockpit. However, for A series, you can use the free drive button even without a license because Teach Pendant is optional. In case of M series, you cannot move the robot by cockpit free drive button without the license. Please look at the number 5 and 6. The cables have a default length. Robot cable is 6 meter and Teach Pendant cable is 4.5 meter, but there is also an option to extend the length. Please refer to the installation manual for details and consult with your responsible salesperson if you want to adjust the length of cables. Partners and customers have to prepare an 8 hex socket bolt, which is number 10 item, for fixing the robot to the base. If you need to fix a tool, you can also prepare an M6 bolt, number 12 item, for securing the tool. Additionally, if you need a positioning pin for mounting, please it be prepared. Also, if you prepare a socket wrench for fixing the bolt, you can install it smoothly. The following is the robot configuration, its part names and functions. Although not in the slide data prior to the introduction, let me briefly explain the inside of the joints module. There is an encoder that measures the rotational number of motors to read the angles of the joints, a motor that rotates the axis by power, a decelerator harmonic drive that reduces the high speed and low torque of the motor and converts it into low speed and high torque, and finally, an electric brake that secures the joint. Let's check the name of each part of the robot in the next video. Base, joint 1, joint 2, link 1, joint 3, joint 4, link 2, joint 5, joint 6, and flange. The connector. Robot connector of M series can be connected and disconnected easily. When connecting and disconnecting the robot connector, be careful not to lose the O-ring for waterproof and dustproof. On the flange, the LED is attached and you can check the robot status in real time. There are 2 I/O connectors. Backside of joint 6, you can find 5 buttons cockpit. Let's continue with A series. The A series also has a similar appearance to the M series. The part name is the same as M series from base to flange. There are 4 things different from M series in the appearance. The position of a robot LED is on the upper side of joint 1. The number of cockpit buttons is changed 5 to 6. And there is 1 flange I/O connector. You can see the robot cable is connected to the base as an undetachable type. Let's have a look at each part. Joint 1, joint 2, link 1, joint 3, 4, link 2, joint 5, and joint 6, and flange. The A-series cable connector is undetachable, but it can be replaced through the base inside after unmounting the robot completely, and currently special cable is ready to apply that users can directly replace from outside in the event of cable damage. So please check it out with your responsible salesperson if necessary. Different from the M-series, as I mentioned before, the robot's LED is located at the top of the first axis. There is one flange I/O connector, and the number of cockpit buttons has been changed from 5 to 6. Next, the shape of M-series control box. You can purchase standard one in a plastic case, and you can make an order steel case as an option. For your information, compared key shape between M and A series. It looks different, but you can open any box cover with either one of them. This is a A series control box. Compared to the M series, the case has been changed to steel material from plastic. The position of robot and teach pendant cable is also different from M series, and shape of robot cable head has been slightly modified like L type to prevent damage. Additionally, the connection terminal of emergency stop button is same as that of a smart pendant, so one of them can be connected. If you have any questions about purchasing DC controller for both M series and A series, you can discuss it with your responsible salesperson. The cover of M series is detachable type, and A series is hinge type. M series has the safety output block and network hub and T-stop 9-pin port, and you can see that the relay is operated as servo on. A series has the dip switch and simplified one Ethernet terminal. There is one USB 3.0 port for both M and A series. Next, the shape of the teach pendant. There is a power button at the top and LED on the screen left upper side. In addition to being illuminated when power is applied, the status of the robot can be checked in the same way as the LED color. There is an emergency stop button on the upper right front, which in case of an emergency can be pressed to stop the robot from operating. There is also a hand guide button on the back side for direct teaching, which has the same function as cockpit free drive version. The smart pendant allows a remote control function to be used. When using the robot in autonomous mode, there are buttons such as play, stop, pause, and resume, and you can also select the robot's mode as manual. You can also use the homing and servo on function. It also has a function key that can be used as a user-specified input signal. The emergency stop button is also available to assist operators in simple operation when using a robot without a teach pendant. You are able to purchase smart pendant as an option only for A series. As mentioned in the introduction of components, you can download that platform appropriate to the robot software version from the Robot website and install it on a Windows-based PC. Well, let's go to the RoboLab website first. And then log in the site. You can see the main menu. We go to Resource and select the software. In this page, you can see the button to download that platform. And we will choose the same version of that platform as the version of robot software. If the version of that platform does not match to that of robot software, that platform cannot be connected to the robot. So you should check the matching between that platform and the robot software version. When we run that platform, the first screen is like this. In my case, the version of that platform is 2.7 and the robot software version is 2.7. They are same. Then I select this item and press the button to connect. Okay, then you can see the program screen. Then you can run and use the program on your PC. It's shown in this picture. It's same as the teacher pendant screen. Before we move to the next slide, let's see more on the RoboLab website. You can go to the manual menu under the resource. In this page, you can find any manuals and download it. Also, you can go to the online courses menu under the training main menu. In this page, you can find many materials kind of for communication, setting, and any other help for you. I'm sorry. And we go back to the slide. Lastly, let me introduce to the enhancers briefly. First is stain-resistant model. The enhanced anti-stain function makes it easy to manage the appearance, even in a work environment that is exposed to contamination. Smart Vision module is an onboard type vision system that can be mounted at the end of the robot. Smart Vision module offers inspection of object presence and measurement of position, angle, diameter, and length. All settings are managed in Teach Pendant with an intuitive user interface for easy use. Well, next is mobile base. It's recommended to operate within 50% of the maximum tool center position speed of the robot and the moment when it's not fixed. For long-term operation, please fix mobile base to the floor completely. Dress pack organizes various cables connected to the end tools of the robot, allowing efficient operation. Integrated tube bracket and holder ensures convenient organization, and it is easy to attach or detach and relocate on the robot. Robot jacket protects the robot from contamination by liquid, and PU coating forms a two-stage water barrier, which ensures to the robot to maintain optimum operation condition. Okay, let me introduce the next chapter, installation of Doosan robot. First, install the base. If it is fixed with 4 M8 bolts and the spacing between bolts is 1 and 50 millimeter, the guide pins are located on 2 diagonal lines as shown. For more information, please refer to the installation manual. Next, the procedure for connecting the robot cable to the controller. This is very simple, but there are some precautions. Fully latch the connector until the snap clicks on the side of the manipulator and pass the cable through the bottom of the controller. Because the pin shape at the end of the robot cable is different from that of the Teach Pendant, you can connect the cable without confusing the location of the cable. Be careful when inserting with excessive force, as the pin located on the controller may bend. When connecting and disconnecting cables to the controller, it is necessary to disconnect power to prevent damage to the robot and controller. To prevent the fuse blowing when connecting the cable, it is recommended that you connect the power cable lastly. After connecting the cable, mount the ferrite core at both ends of the cable, as pictured, to prevent the noise. The Teach Pendant cable connection method is the same as that of robot cable. Likewise, be careful when inserting with excessive force, as the pins located on the controller may bend. After connecting the Teach Pendant cable, attach the ferrite core to the end of the cable. Please be careful to ensure that the robot cable and the Teach Pendant cable curvature radius is greater than the minimum curvature radius, 1 and 20 millimeter, during routing. If the curvature radius is smaller than the minimum value, cable disconnection or product damage may occur. Finally, connect the power cable. The power cable we provide has a snap device, so we pull it out. When you pull it out, it doesn't fall out immediately and is stuck in the snap. When you turn on the switch next to the cable connection, you can hear the fan turned on, and when the LED on the internal PCB lights up, you can see that the robot is normally powered up. Then press the power button on the top of the Teach Pendant for 2 or 3 seconds to see that the red LED flashes and boots. But let's take a look at this video. First, connect the robot cable. And next, connect the teach pendant cable. Then fit the ferrite core to prevent noise. And last, put the power cable on. Please note that for A series, the connecting direction of the robot cable and the teach pendant cable is vertical. Please refer to layout configuration. Next is operation area. Please refer to the image for understanding operation area. The blue part is the actual operating area you can work on, which is slightly different from the maximum reachable area. This means that the maximum working distance and the actual working distance, given the tool orientation, are different. Tool length can take a benefit at the end of the flange, but if the center of gravity of the tool is getting far from robot, the amount of torque of each axis and the momentum increase and the payload decreases accordingly. So the layout can be configured using the payload diagram and the detector's workspace. The difference between the maximum reach range and the effective working range of M1013 is approximately 121 mm. When the robot arm is straightened, it is easy to move only in the direction of the ellipse. The position for easily moving the end is the highly effective working area. Therefore, it is recommended that you make a position that the robot can move in an effective smaller space than the robot's entire working space for precise operation. If the robot joints are straightened out, a singularity occurs. Near the singularity area, the robot motion corresponds to a plane, point, or a straight line, making it difficult to move smoothly. And it also gets in trouble to move straight at the end of the robot and increases positional error during control. This occurs only in linear motion, and for the rotational movement such as joint motion, the singularity does not affect. In addition, when the path of a linear motion passes through the singularity area, it's not possible to use force or compliance control, and violations occurs due to the angle speed limit can be induced because the rotation speed of a particular axis is rapidly accelerated. Of course, Doosan Robot offers an option to avoid singularity in motion control, but we recommend using the Move J command instead of Task Motion command. The singularity occurs when the fifth axis corresponding to the wrist is straightened, or the third axis corresponding to the elbow is extended, or the first axis and sixth axis are on the same axis line. Linear motion is unnatural in the singularity area, and force compliance control are not possible. Next, payload diagram of M series. Within its allowable payload range, the robot's maximum payload depends on the distance to the center of gravity. The following diagram shows the payload relative to each distance. You can see that each axis in the left diagram and the axis shown in the right robot arm have the same direction. As the center of gravity moves away from the tool flange in the Z direction, the weight that the robot can hold is gradually reduced. The diagrams show the maximum weight when the robot is moved at maximum joint speed. If you want to use a heavier workpiece or a wider range of center of gravity, you have to slow down the joint speed and monitor the torque for each joint with Dart Studio. If you determine that the robot is safe to use for each axis, you can operate the robot in the larger area than the maximum allowable range in the diagrams. This part can be difficult for general users to approach, so let us know specifically about detailed operation information such as the tool center of gravity, weight, position, and speed. We can help you with verifying the possibility. This is a payload diagram of A series and H series. Please note that A series has a larger allowable payload area compared to M series based on the same payload. Okay, let's begin the third chapter, electrical interface. In addition to the manipulator and teach pendant, various external equipment can be connected to the control box through the control box I/O terminal. Various peripherals such as safety devices, including emergency stop switch, light curtain, and safety mats, can be connected. And devices required during robot work cell setup, including pneumatic solenoid valves, relays, PLCs, and conveyor belt encoders, can be also connected. The control box I/O consists of the following 6 units, as you see in the slide. Before we move to the next, we need to be careful of the following. Please turn off the power when connecting terminals to the control box I/O to prevent product damage and breakdown. The manufacturer will not compensate any product damage caused by inappropriate terminal connection or user negligence. Please make sure to turn off the external power source when turning off the control box power. This is A series control box I/O. The difference is that there is not terminal block for safety contact output compared to M series, and dip switch is added. The safety I/O of the control box consists of dual contact input terminals for connecting safety devices. These terminals are categorized into 2 groups depending on their use. The first one is 2 pairs of external emergency contact in on the left. This is used to connect devices required for emergency stopping, such as external emergency switch. The second one is 2 pairs of protective device contact in on the right. This is used to connect devices for protective stopping, such as light curtain and safety mat. There's one thing to remember for safety. Do not connect the safety signal to regular PLC that are not safety PLC. Failure to do this will result in inappropriate operation of the safety stop function, which can cause severe to the user. If no external safety device is connected, connect each contact input as the picture at the top right corner. The table in the middle of this slide shows the external safety device signal recognized by the safety controller depending on the normally closed contact status, where all 4 contact inputs are normally closed. If one of them is opened, the robot is stopped in accordance with the safety stop mode setting, and LED on the right of terminal block for safety contact input is lighted. To check for connection losses and connection shortages, this terminal must be connected to devices that output a safety signal as contacts. To connect peripherals that output safety signals as voltage to the safety controller, refer to the description for the configurable digital I/O terminal block. When the robot is safety torque off status, each of the 2 relay ports opens and sends safety signal to external devices. While the output value of the 2 contacts must be identical, different output values may be generated when open or close takes place. If the output values of the 2 contacts are longer than the times in the table below, assume connection shortage and hardware defect of the connected external device and perform inspection. The rated voltage and current of the safety controller relay connected to the contact output terminal is 250 voltage and 6 ampere. If a user uses a current of 2 ampere or less for the configurable digital I/O, and if there is no insulation for the connected I/O device and control box, the internal power supply of the control box can be used as the I/O power supply as is shown in the figure. This is a factory default setting. If a current greater than 2 ampere is used by the connected VCC and ground of power terminal block, the fuse in front of the terminal power output shorts to ensure the safety of the control box internal system connected to the same MPS. If a current greater than 2 ampere is required for the configurable digital I/O, make sure to connect an external power source to VIO and GIO. I/O power LED located on top of the power terminal block light on if VIO power is supplied. As I mentioned before, please make sure to turn off the external power source when turning off the power of the control box. The digital I/O of the control box consists of 16 inputs and 16 outputs, which are PNP type. The relay is needed for NPN type. They are used to connect peripherals required for robot control or are set to dual safety I/O to be used for safety signal I/O purposes. If the configurable digital I/O is used as a general digital I/O, various low current operations such as solenoid valves for voltage and signal exchanges with PLC systems or peripherals can be performed. The VIO and GIO terminals that can be used as power supplies for digital I/O are separated from the VCC and ground of other power supplies on the safety I/O circuit. Take caution as the diagnostic functions of the robot will detect errors if the internal power supply is connected as a digital I/O power supply through the terminal block for digital I/O power, or if 24 voltage power is not supplied to the VIO and GIO terminal through an external power supply, the configurable digital I/O does not work and shuts off operating power to the robot. The control box has two analog I/O terminals that can be set to voltage mode or current mode. It can output voltage and current through an external device operated using analog I/O or receive signals from sensors outputting analog voltage or current. To ensure maximum input accuracy, observe the following. First, use shielded or twisted pair cable and connect the cable shield to the ground terminal inside the control box, and use devices operating in current mode for analog I/O terminals because current signals are relatively less sensitive to interference. Current or voltage input modes can be set with the software. The control box provides two encoder terminal blocks that allow the input of external encoders. They support A, B, and Z phases as inputs and perform counts based on 12 VDC. In addition, S phase can be used as the conveyor start sensor. The figure on the right side shows a sample encoder and sensor configuration, so refer to it while establishing connections. To ensure maximum input accuracy, as I mentioned before, observe the following. First, use shielded and twisted pair cables to reduce noise, and connect the cable shield to the ground terminal inside the control box. The end flange cover of the robot has two M8 8-pin connectors. M and H series have two connectors, and A series have one connector. The two connectors supply power and control signals necessary to operate the gripper or sensors embedded within specific robot tools. Internal power of flange I/O is set to 24 voltage and 1.5 ampere. Maximum 3 ampere can be supported. As an application, 24 voltage and ground terminal can be used for input and output, so simple power to vision tool can be covered by flange I/O. The number 5 terminal of each connector outputs 24 voltage at all times, while power is supplied to the robot. So make sure to cut the power supply to the robot when setting up the tool and gripper. And be careful to avoid a dangerous situation such that workpiece falls from the tool when cut off the power supply to the robot. Each connector of M and H series has 3 digital inputs and 3 digital outputs. A series have a little bit different configuration. It has one connector, it has 2 digital inputs, 2 digital outputs, and 2 terminals for RS485 serial communication. The flange connector we recommend is 1404178 and 1404182 connector of Phoenix contact. The former is straight type and the latter is angle type, which is bent in the -Z direction. If you want to rotate the connector direction by 180 degrees, which is bent in the +Z direction, when purchasing Doosan Robot, please consult with your responsible salesperson. If you have a different brand connector with the same type and specification as those 2 connectors, you can use it with the flange. In the case of A series, 24 voltage power of the flange I/O is cut when the robot becomes servo off. So configure the tool and gripper to avoid a dangerous situation when handling the workpiece on the tool. The digital output of Doosan Robot is source type, therefore, Please take this into account when you interface the Doosan robot with other electrical devices or equipment. This is a short video shows different shape between M&H series. Next is network. External Internet, TCP/IP equipment and Modbus equipment can be connected to the network router inside the control box. You can connect cables to dedicated ports according to the network application. One port is for connecting external Internet and LAN port is for connecting peripherals using TCP/IP or Modbus protocol. Connecting the cable to the network connection terminal will connect the network. The LAN 4 port is used to connect internal controller, so do not connect other equipment. A series controller or DC controller have one LAN port. If you need to use more than one Ethernet communication for your system, we recommend to use an industrial hub. As a table, the peripherals using TCP/IP or Modbus protocol can be connected without gateway. The devices using the others, just like Ethernet IP, Profinet, Syslink, and so on, can be connected with a gateway referred to the table. There is a D-sub 9-pin port as an interface in M-series model. You can use the D-sub port to connect a device that supports RS-232 serial communication. And there is also a USB 3.0 port, which can be used to import and export a file with USB flash memory drive and to update, backup, or recover software. USB flash memory should be formatted by FAT32 type to import and export a file. The USB port can be also used for RS422 or RS485 serial communication with USB to RS422 or USB to RS485 converter. If you need USB connection more than one, you can use USB hub for expansion. Okay, now let's continue to the Chapter 4, Safety Recovery. When booting the robot, you can press and hold the power button on the upper left side of the teacher pendant until the teacher pendant screen turns on and the LED on the front of the teacher pendant flashes red. The LED on the teacher pendant shows red flashing status until the robot controller is connected to the network. When the boot is completed, the LED will change from flashing to red. To turn off the power, press and hold the power button for 3 seconds and press OK button in the pop-up window. Press and hold for more than 7 seconds to force the robot to shut down. Please be careful not to lose unsaved data during program creation because the button is protruding. When you boot the robot for the first time after purchase, the emergency stop button is pressed to display a running pop-up. If the emergency stop button is pressed, even if it is not the first time the robot is booted, the emergency stop button must be released. Turn the stop button clockwise to release the emergency stop state. Let's operate the stop switch on the M series and try servo on in status menu. Well, go to status menu and press the servo on button. Please look at the LED for checking color changes. This is A series. Yes, as before, we will operate the emergency stop button and try servo on in a status menu. For A series, the LED turns off as servo off, and the brake is released after checking the communication connection for approximately 3 seconds after pressing servo on button. When the robot is turned on and that platform is connected, this home screen appears. After unboxing, booting the robot, press the status button at the bottom right of the screen to enter the status menu. You must press the servo on button to release the brake and supply power to the motor. The servo on status refers to the ready state in which the robot is powered up. However, when the power is supplied for the first time, that means after unboxing and initially operating a robot, the servo on button triggers an alarm related to the angle limit to maintain the servo off state. You can also see that the robot's LED is still red. In the packing state after taking the robot out, it's not possible to switch to the servo on state because the robot arm is located in a position that exceeds allowable angle limit. To enter the servo on state, simply enter the recovery menu and use the pack unpack mode. In the servo off state, enter the recovery menu at the top of the screen. Enter the recovery menu, select the pack unpack tab on the right, and press the package mode toggle button to activate the packaging mode, and then press the unpack button and hold it to make the robot available position to operate. During operation in recovery mode, you can see that the robot's LED flashed yellow. Move the robot's arm to the available range without having to raise it to the end. Then press the back button to go back to the previous screen to see the robot's LED turn blue and the robot status at the top right of the screen change to ready. You can also see that the status screen is switched to servo on in the upper right corner. If the robot is in the packing position, an angle limit alarm will occur even when you attempt servo on. In this case, servo on is only available from the pack unpack tab in recovery. Go to recovery menu and select the pack unpack tab and switch on the package mode. And you can see the lamp flash yellow, and press and hold the button to unpack. The robot will only move while the button is pressed. For A series, the packing position is slightly different from M series, especially the first axis is rotated 180 degrees to protect the robot cable. You can see the comparison of M and A series unpacking movement. When an emergency stop is occurred by external forces, such as collision, the robot can be manually operated and be entered into safe area using the direct teaching button. If the robot is stopped due to the crash, enter the recovery menu as before and execute the recovery operation. After entering the software recovery state, press the servo on button on the upper right side to manually operate the robot using the direct teaching button. You can move the robot to the safe area. For your safety, the direct teaching function is set to insensitive. That means more forces needed to manipulate. Alternatively, you can select the joint axis and press the plus-minus button to move it, and also use the speed slider to control the robot's moving speed. Now let's watch the video about the recovery process. After entering the software recovery state, press the servo on button on the upper right side to manually operate the robot using the direct teaching button. As you can see, the lamp LED flash yellow. You can move the robot to the safe area. And as in the video, you can select the joint and press the plus minus button to move the robot to the safe area. 23 is moving, and the others can. The following is the back drive mode. This is another way for recovery. Actually, if a collision occurs, in most cases, we can recover through the software recovery mode or using joke to get out of the dangerous area simply. However, if it does not work, in that case, physically and manually, we turn off the brake and restart the robot. In that case, we have to rotate the motor manually, so we have to turn off the current to the motors and the brakes and move the robot manually. The back drive mode is for that case. As before, you can enter the back drive mode while it is in servo off. The robot must be rebooted after completing operation in back drive mode. Click Start Back Drive Mode and release the brakes one by one on each axis to move the released joints by hand to move the robot into the safe area. The robot must only be moved by force, so it moves quite stiffly. After robot movement, deactivate the toggle switch again. Once you have finished, simply press the power button at the bottom right of the screen to turn off the power and restart the robot. In the servo-off state, you can go to the back drive mode and press the button of a back drive start. With the power of motor switched off, let's release the brakes on each axis and apply force to rotate the shaft. The decelerator needs to be rotated, which requires considerable torque. the LED flash yellow, just like the recovery mode. Reboot the robot after the recovery is completed. Okay. Do you have any questions about safety recovery? If you have, please use the chat in Zoom. Okay. Let's move to the next chapter, manual operation. When you enter the jog menu, you can find 3 tabs: jog, move, and set in the left. Each detailed explanation will be followed in next few slides. There are 2 main differences in robot movement. Given the robot's target position, there is a joint movement which calculates the joint angle at that position and then moves only towards the target angle of each joint. At this point, the trajectory is arbitrarily determined. The other is a linear movement or task motion in which the tool center position moves straight from the current location to the target location. When the real mode is turned off, the robot will only move on the virtual screen. The actual robot will only move with the real mode. When the joint motion is selected in jog mode, the robot can be moved by selecting the axis, then pressing the plus/minus buttons. The robot moves while the plus/minus button is pressed, and the screen shows the current position of the robot in real time. And the speed slider at the bottom can be adjusted for moving speed. Due to the feature of joint rotational movement, the trajectory is not that important, so it is used for speed-oriented tasks such as transport and loading and unloading, and it is necessary to check if there is a collision during operation. Joint motion is the fastest motion among all motion commands. In jog menu, with joint motion, you can select the axis to move the robot by pressing plus/minus button. Joint 2, joint 2, joint 3, moves like that. Joint 4, yes, joint 5 moves. Joint 6, yes, take a look at the flange is rotated. Select task motion in jog menu to move the tool center position. In this case, a gripper or a tool is not attached to the flange, the middle of the flange is the tool center position. Select the coordinate system, either base or tool coordinate, then choose the direction X, Y, Z, Rx, Ry, Rz. When task motion is selected, as shown on the screen, the joint is not selectable and only the current real-time position is displayed. Task motion is useful for welding. The trajectory is important between current position and target point, and sometimes the speed adjustment is required during movement and moved in a straight line to avoid collision on a plane. Yes, as in the video, the task motion shows kind of a linear motion. You can select the XYZ, RX, RY, RZ to move the robot to the target position. On the Move tab, you can move the robot to the target angle and coordinates. After entering the target joint angle relative to the joint, press the Move to Dispose button to move the robot to the location you entered. The robot will still move while the button is being pressed. You can use the speed slider as well to adjust the robot moving speed, and you can enable and disable the real mode button. You can select the task motion in Move tab. First, press the Reset button to initialize and save the current position. Then enter the target point and position, and press the Move to Dispose button to move the robot to the target position while the button is pressed. Note that if you release the button and press it again, the button is the Move to the Disposition. If you release the button and press it again before the robot reaches its intended position while moving, it can move away from its initial target position because the robot moves relatively from the starting position where you stopped. Let's watch the video as a demonstration of move function. As I mentioned, enter the target position for each joint and then press the Move to Dispose button. You can see the robot move to the target position. And we can select task motion. Press the Reset button in the base coordinate. You can save the current position after entering the target position, and then press the Move to Dispose button. You can see the robot move to the target position. You can also change the coordinate base to tool and do the same thing to enter the target position. And then press the Move to Dispose button to get the robot to the target position. If you miss to press the Move to Dispose button before reaching to the target position, you can bring the robot back to its original position by selecting the base coordinate again and press the Move to Dispose button. Then the robot gets back to the original position. Alternatively, if you are not sure if you can move the robot to the desired position at once, it's an idea to split the short distance and move several times. This time, I will introduce an alignment function. First, parallel to coordinates, you can align the tool coordinates and the base coordinates. Tap the basic motion in the Set tab, select the coordinates and tool axis and target direction aligned with the axis. Then press the parallel axis button to move the robot TCP. If the base is installed parallel to the floor, even you select world coordinate system, the result will be same. But if the base is installed on the wall and select the world coordinates and align to z-axis direction, the robot position will be different. You can also move the robot to its home position. About home position setting, it will be explained in next chapter. Now, this is parallel to target alignment between tool axis and specific axis. When you specify 3 points, you can align the coordinate axis at the end of the robot that is perpendicular to the plane created by 3 points. Please take a look at the following video for better understanding. In a simple practice, first select the base coordinate as the reference coordinate system and set the tool axis as z-axis to align with the z-axis of the base coordinate. The robot through center position moves and completes the alignment. Let's try to have a practice in real robot. Okay. First of all, go to status and make it robot the server on. And go to jog menu and select the set, and you can select the basic motion tab. We choose the coordinate is base, and we can choose the tool axis as Z, and target direction is down. And let's try to make the robot aligned. Press the button parallel axis. As you see, the robot is aligned well as we intended. If we change the tool axis to Y, and the robot will be realigned like this. Okay. And we can have a practice is parallel to target menu. We choose the coordinate as base and z-axis, and we're gonna set the 3 points clockwise. As you see, 3 points were set, and let's press the button parallel axis. The robot was aligned with the direction it just reset by setting the 3 points. If you use the target align function as an option, turn on the toggle switch. On point 4 and specify the desired position. Then let's try to make the robot align. You can see the tool center position aligned in the 4th position, like lastly saved, and in the vertical axis of the specified plane as before. You can also align the tool center position parallel to the work cell item, such as palette, if you registered. If you need, please refer to work table alignment information. Next, cockpit button for direct teaching. When pressing free drive button, number 1 in the picture, you can move the robot freely. Each joint of the robot moves in the direction of the user applied force. If you release the button, the robot cannot be moved manually. You can see that the LED is blinking cyan color. When pressing constraint motion button number 2 and 3, the end of the robot moves only in the direction of the constraint condition, even if the force is applied in any direction. 2 of the 4 constraint motions can be specified, and we will learn more about how to use in the next chapter later on. Press the hand guide button on the back of the teach pendant to move the robot in free drive mode. It functions as the same as the cockpit free drive button number 1 on the previous slide. The LED colors are also various depending on the robot status. The first boot is flashing red, then continue red when the boot is completed, and change to blue when servo on in manual mode. When the servo off state is displayed for reasons such as protection shutdown, safety limit exceeded, and etc., it is displayed in red and yellow for recovery. For details, refer to section 5.3 in the installation manual. Let me introduce the configuration of the robot basic setting. You can find a setup window by pressing the setting button at the bottom right of the home screen. Select the locale menu for language, setting, and reboot required after changing the language. Select the date and time menu to change the date and time to match the time the user is in. The robot setup menu allows you to set the home position. The home position has two positions, default position and custom position, that performs auto mastering pressing the home position button. This button is located in jog menu, and we already checked in the previous chapter. The default position means that all axes are at 0 degrees like factory status. The custom position means that the user modifies the joint angles as per user's environment. If you select either default or custom position, the robot moves to the specified position. You can easily specify a custom position by using Cockpit. Set the robot to the desired position in the free drive mode, then press the Get Pose button and the Confirm button. Let's have a practice. First, we go to Setting and select the home position. We're gonna set the custom home position. Okay, we set the custom home position and we need to confirm. And now we can test. Move to jog menu and basic motion. We have the home position button. Now press the home position. For test, I will move the robot to different position. Okay, we can see the robot move to the home position we have set. And you can set the constraint motion in Cockpit menu. You can assign one of 4 constraint conditions specified for each button, 1 and 2. Please take a look at the following videos in next slide. When you select to set the position Z, you can only move the robot in Z-axis direction when you move the robot manually. When TCP XY is selected, the robot can only move in the XY plane and cannot move in the Z direction. In case of the TCP position only, you fix the TCP and move the robot only the directions. Let's practice the other 2 options. Let's set the number 1 to orientation and number 2 button for position and confirm. Okay. Now if I press the number 1 button, oops. The robot only moves with the constraint condition. And when I press the number 2 button, the robot keep the orientation. The function is, the next is remote control function. The function is to activate the remote control as the word itself and make the robot to perform a servo on, task start and stop, and etc. Tap use remote control toggle button and set input and output signal and default load task. But if the safety input signal is not set, the input output signal and default load task cannot be selected. You must set remote control mode and remote emergency stop on the work cell manager and safety I/O and input menu. When finished, you can start the remote control mode by pressing the start remote control button just beside the toggle switch. Okay, let's have a screen in that platform. We can practice this function. We just see the menu. For this function, we go to work cell manager and select the safety I/O, and need to set the emergency control and emergency stop property, and press the edit button and press the password, and you can select the port as an input. Now, as I mentioned, the remote control enable and remote emergency stop, like that, like the draft. And finally, we need to confirm draft, but we're not going to use this. Okay. The next is multi-user mode. Depending on the permissions, you can control the robot functional settings through multi-user mode. You can also set a separate password for each user. If you enable the multi-user mode, a screen will appear asking for the administrator password. Simply enter your administrator password to complete the setup. When the user permission changes from off to on, it moves to the home screen and switches to the operator account. Note that if the multi-user mode button is disabled, it works the same as the administrator account. You can set a password and turn it on off. If you turn off the password lock tapping toggle button, all password protected features will not display a window for entering the password until you reboot. Let's have a look at the screen on that platform. Safety password. Yes, I entered the password. remember the password requiring pop-up was showed, and I turn off the password lock button and go to the other menu and go back to the safety password menu. Yes, we don't see the pop-up window for requiring password. The network menu allows you to register settings for communications. In the controller menu, you can change the controller's IP address to communicate with peripherals. And in the Modbus menu, you can register the slave devices. In this case, the robot is master client. The update menu lets you check the current software version and update if necessary. Please be careful not to remove or turn off external storage devices. If it is removed or turned off, the robot may be damaged or cause the update failure during the update. Please restart your system when the update is completed. Well, actually, after software version 2.7, which means from version 2.7 to the next version, the update process is simplified. The software can be updated by once. Please refer to the RoboLab website for the update method from version 2.7. You can see it, Training Online Courses menu. We take a look at again. Training and online courses, and you can see the video of introduction of software update. If you click View Details button, you can watch the video. And next, license code. You can check the model number and serial number of the robot and enter the license code. Serial number, model number, and license code can be used for supporting customer service. If a license update is required, please enter the newly issued license code and restart the system. You can check the logs that occurred in the teach pendant, and you can send the data by using tplog command in the task to log message. You can retrieve log records on a monthly basis, and you can also delete logs. You can save logs that occurred during robot operation. Save the log data to USB flash memory. You can search for periods on a weekly basis, and you can also select the log type. Factory initialization is the ability to delete user data and logs stored on the robot. The database, log files, work cell items, and task files are deleted when factory initialization is executed. When the factory initialization is completed, the system must be restarted. If the teach pendant is not used for a set period of time, that means without input via teach pendant, the teach pendant will enter screensaver mode. The robot enters screensaver mode even if it is operating in autonomous mode. The default value is to use the screensaver. You can set how long the screensaver will operate in minutes, and the maximum time is 1414 minutes, which is 24 hours. You can set up idle server off to automatically go to the server off state when the robot is not physically moving for a specified amount of time. The default value is 5 minutes and can be changed to a user-specified time. You can back up and restore some of the data used in the teach pendant. The file extension is .append when backing up for appending, or .replace when backing up for overwrite. Let's take a look at the backup features first. Select the proposed backup data during append and overwrite first. To backup your full data, select the Backup Entire Data checkbox. Just like this. And then click the Backup button at the bottom of the screen. To backup individual data, select the checkbox for the items that you want to back up. Things like that. And then press the same button. To restore the data, first select Restoration Type, Append or Replace, then press the Restoration button. When the Select Files pop-up window appears, select the file and reboot when the restoration is completed. Data restoration is only possible on the same version of the current software, the same series of robot models. When you restore a backup file that contains a work cell item, all work cell items that can be disabled. If you restore to a robot that does not have a license for the item that you want to restore, the restore will perform normally, but you will not see the licensed item. When appending the backup to the existing data, the restoration will be aborted if the maximum number of add-ons is exceeded for safety zones, tool weights, tool shapes, user coordinates and effectors, and system variables. For more information, please refer to the Backup and Restore section of the user manual. And today's class is finished. Thank you for your attending to our online basic training. Thank you very much.